Alright, Harley is building a model of a city map. In one part of the city, 3 roads form a right triangle, which Harley draws as triangle ABC. With the following measures, measure of angle B is equal to 90 degrees, and measure of angle A is equal to 30 degrees. In his scale model, the hypotenuse of the triangle ABC, segment AC, has a length of 8 square roots of 17 centimeters. What is the value of A, the length of segment BC? Okay, so in this lesson, you learned about sine of an angle and cosine of an angle, and they're just ratios. They're called trigonometric functions, or short as trig functions. You have a couple requirements. It has to be in right triangle, and you're using them to find a missing side length. You also require to have one angle besides the 90-degree angle and one side length. So when I look at this, I'm looking, okay, I have a right triangle right here, 90 degrees. There's also another tool that we could debate between to find side lengths, and that's the Pythagorean theorem. Now, the Pythagorean theorem also, you have to have a right triangle. And you have to have 2 side lengths. So on this, where I only see one side length, that automatically makes me think of the trig functions, and they give us a 30-degree measure there. So we're going to use our sine and our cosine. So we have sine of an angle. They usually use like theta is equal to the ratio of the opposite side length divided by the opposite side length divided by the hypotenuse. The cosine of an angle is equal to the adjacent side length and the hypotenuse length. So the very first thing we've got to do is we've got to decide what is our angle. I know that I used A here. That was just generic. The angle that we're going to use is the one that they give us, which is 30 degrees. Right there. So we either have sine of 30 degrees or cosine of 30 degrees. We're going to see which one we want to use. We're going to label this triangle based on the angle, our 30-degree angle, as our perspective. So I sometimes like to draw like a little eyeball right there, so I know it's my perspective. The first side length that I always like to label is actually the hypotenuse, because it's always directly across from the 90-degree angle. So that's the hypotenuse. This perspective right here of this angle is what's going to help me label the other 2 side lengths. From this perspective, this angle, if I go directly across, the side length that's directly across from the angle is called the opposite. And the side length that's touching this angle that's not the hypotenuse is the adjacent. Adjacent means next to, so it is next to it. Now if you look, the opposite side length is represented by little a and divided by the hypotenuse. We have 8 square roots of 17. And then our cosine is our adjacent side length, which is b to a. And that's going to be divided by our hypotenuse side length, which is 8 square roots of 17. I'm doing the square root of 17 because I don't quite have it quick enough in there. So now we are going to decide which of these is really what we want. We want to find side length BC, which is represented by little a. So then I look at between these two. The one that has little a in it is this one. So I'm actually going to jump over to Symbol Lab and type in Sine of 30 is equal to a divided by 8 square roots of 17. If you hit go, here are the steps. It says to switch sides. You don't necessarily have to switch sides. Okay, I don't like these steps. I have a way that will show you quicker. Their way is correct. It's just kind of a long roundabout way. So again, we had sine of 30 is equal to 8 divided by 8 square roots of 17. Well, I'm trying to solve for a, and it's being divided by 8 square roots of 17. So I'm going to multiply both sides by 8 square roots of 17. And I'm going to multiply sine of 30 by 8 square roots of 17. That is because 8 square roots of 17, even though it looks like a weird number, it is being divided by the exact same number, 8 square roots of 17, and that reduces down to 1. So then we are left with a is equal to 8 square roots of 17 times sine of 30. So then we can jump over to our calculator and type that in. 8 square roots of 17 times sine of 30. That's going to equal, gives us 4 square roots of 17. That is the exact value. If you notice, it says enter the value that fills in the blank in the previous sentence. If necessary, round your answer to 2 decimal places. Okay, well this says 16.492. Well, since we're rounding to 2 decimal places, we want to look at the thousandths, which is that 2. 2 is less than 5, so we're closer to 16.49 than 16/50ths. So we are going to type in 16.49. That's how we will answer this question.